What's up, guys? Let's talk about the different ways a client can communicate with the server. We'll talk about all the major transfer protocols, and let's first start talking about the World Wide Web. So let's get into it. So, the World Wide Web. So, the global network of computers that provides information and communication facilities using some standardized protocol is known as the Internet. The World Wide Web, or the WWW, is referred to the interlinked resources that are stored across these interconnected computing machines. These machines are broadly classified into clients and servers. The communication between the client and server is carried out with the help of an API, right? So before digging into APIs, let's understand the World Wide Web and Hypertransfer Protocol, HTTP, and these concepts will further pave the way for REST APIs, which is majority of the internet today. So there are many technologies for client-server communication. We'll focus on HTTP, RPC, and WebSockets. These are all the major client-server protocols, and we'll get into those. These three cover the majority of the client-server communications, and we'll start with the World Wide Web since it's the primary use case for an HTTP protocol. So let's talk about the World Wide Web specifically. The World Wide Web is a hypertext-based information system that interlinks documents spread and stored across millions of machines all over the internet. This is commonly known as the web or Web 3. The World Wide Web was launched by the European Center for Nuclear Research, CERN, in 1989, so just a little bit of a history lesson. And at the Hypertext 91 conference, academics were drawn to a public demonstration which inspired Marc Andreessen of University of Illinois to create the Mosaic, the first graphical browser, in February of 1993. And so let's talk about what's the difference between the internet and the web. So the internet is a network of networks. So it's like the whole thing with a series of interconnected nodes that can communicate with each other. But the web is like one part of the internet. The web is one of the applications built on the internet, right? So let's talk about the basic terminologies used when talking about the web. In a broad aspect, the web is a combination of the following four basic ideas. So, firstly, there's a client-server model. The client and server are two different entities connected together via the internet. The client requests a resource while the server provides the requested resource. So, for an example, a web browser, which is the client, and the DNS domain name resource server, a user types a URL in the browser and the DNS returns the web server's IP address. And another big idea is resource identifiers. So this is like a unique identifier to locate a resource such as a file, a document, or other sources over the internet. So for example, we have this Wikipedia page here for the University of Illinois, and that'll redirect us to a resource or a page in Wikipedia. So having these unique addresses is a major idea when talking about the web. And hypertext and hypermedia. So hypertext is a text that is not linear, right? It contains links to other documents where readers can float freely from one document to another. Hypermedia is just an extension of hypertext. So along with the text, the document contains multimedia content such as graphics, animations, images, videos, audios, interactive elements such as embedded programs. And for example, some website may have images. When a user clicks on that image, the website directs the user to another web page. And another major idea when talking about the web is markup language. So, markup language includes a set of symbols inserted into a text document to configure and style its structure, formatting, or connection between its parts. So, for example, this HTTP text right here is an example of markup language, right? So you have like your headers, your paragraphs, divs, etc. And let's talk about web protocols. So the web follows the client server model, right? We've talked about this a lot. And so there should be well-defined protocols to make their communication interoperable, right? So the client application, usually a browser, will display the data received from the server in a specific format, usually a web page, or at least in this case, it's a web page. This information flow between client and servers is directed by a protocol called Hypertext Transfer Protocol, HTTP, right? Application layer protocols such as File Transfer Protocol, FTP, Simple Message Transport Protocol, SMTP, HTTP, and so on, they use lower level protocols like Transmission Control Protocol, TCP, User Datagram Protocol, UDP, and Internet Protocol, IP, to provide services to end users. And we'll discuss all the protocols that are deemed essential. So, how does the web work? From the user's perspective, the web is just a collection of web pages that contain links to hundreds of other objects stored on different machines. Clients run a web browser software while the server runs a special software known as a web server software. Web server software runs on clusters or a few high-end machines. The web servers get services from other backend services such as database services, blob storage, and other application servers. So, for example, say you're like on your phone and you want to access, I don't know, like Target's like web page, right? You want to go to target.com, you do an HTTP request, and then you make another API call to Target's data servers, and then it'll look in their databases to populate the web page, and it'll send back a response, right? Simple enough. And the Internet Protocol, IP, is the unique address of every computing device on the internet. So this is used to uniquely identify the device on the internet or a local network. When a client has an IP address and sends a request to a server, the server provides the required data to the same client identified by 5 tuples: source IP, source port, protocol number, destination IP, and destination port, right? So this is something to keep in mind. And when a client receives the response, the browser reacts accordingly and displays the data as a web page with images, videos, scripts, etc. So your client usually knows like how to present the data that's returned, or in that HTTP response, it'll tell you what type of content it is, so your browser or the client knows how to display it. Something we'll get into. And so what happens on the client side? A client accesses different resources on the World Wide Web. Let's understand the structure of a web resource before describing the steps needed to get that resource. Resources over the internet are identified using a Uniform Resource Identifier, or a URI. And that consists of 3 parts. So firstly, we have a protocol, we have a domain name, and a unique path to a specific page, right? So this is like a typical, web address. You have your protocol, which is, in our case, usually always HTTPS. And then you have the domain name. This could be like Google, YouTube, Wikipedia, and then you have a path. designating like what resource exactly you're trying to get. So protocol HTTPS is used here, and the domain name. So the domain name is the DNS name where the web page is located. So say you're going to google.com, you first have to call the DNS service, right? We have to call that server, and it'll return back an IP address, and that's how we know what internet protocol, what the address is, or what server we're trying to access, right? And then we have our unique path. The unique path determines the web page that needs to be accessed within a domain. So here we have like the browser performs the following sequence of steps while fetching a web page or a resource. So a user clicks on a link, right? And the browser determines the web page URL. For example, we're trying to go to youtube.com, right? So we have youtube.com. And then in the next step, the browser will ask the DNS server for the IP address of youtube.com, right? So it goes to the DNS service right here, and it'll ask, hey, like, okay, what's the IP address of youtube.com? And the DNS server provides the web server's IP address where the web page resides. So it'll come back with the IP address. So we know where to look, or we know, where we can do our client server call, right? And then the browser makes a TCP connection with the server that has been specified by the DNS server, right? And then the browser asks for the web page using the HTTPS protocol. So it'll send the request to that server that we got back from the DNS server, right? And then the server sends the page in a response to HTTPS requests. And if the fetched web page consists of URLs of other objects that are needed for display, the browser fetches all of them using the same process. So the server will respond with the required documents. And then finally, the client or the browser will display the web page to the user, right? And after fetching all the required web pages and the relevant objects, the TCP connections are terminated, right, between our client and server. So what happens on the server side? So the server is constantly listening to fulfill clients' requests. The sequence of steps the server performs is given below. The server accepts a TCP connection from the client, right? So, a client will call a server. The server will accept the TCP connection. The server receives a request from a resource identified by a unique URI. So it'll receive a request and for a specific resource, and the server populates the web page from the database or cache. So either this information will be in a database or a cache, right? And then the web page's content is sent back to the client as an HTTP response, right? And then the connection is terminated, right? So simple enough. And in summary, so we described the World Wide Web and how it works. And we also described the 4 essential components of the web: the client-server model, hypertext and hypermedia, resource identifiers, and markup language. We also discussed the steps involved when a client requests a resource from a server over the internet with the collaboration of different protocols in the process, right? So we're using TCP, HTTPS. We're also calling the DNS server. We're also, terminating that TCP connection. These are all things we discussed. And let's do a quick quiz. So what's the difference between static and dynamic web pages? I think maybe you probably have heard of these terms. We'll go ahead and answer it. So a static web page they're based on Web 1.0, where content stored on the server is delivered to the client as is. But dynamic web pages emerged because of Web 2.0, where the end users interact with the page and dynamic content gets rendered on the client side. So this is generated by a server-side script, or application can change automatically, right? So static web pages stay the same and dynamic web pages change. Sometimes there's scripts or other resources that are sent by the server. And hopefully you learned something. Leave a comment, subscribe. Let me know if you have any suggestions. Thanks for watching.